Okay, this is a tutorial for looking at different parts of the periodic table and identifying protons, neutrons, and electrons in both atoms and ions. First, in this periodic table doesn't show everything, but what this periodic table does do, it covers some things we don't cover. It talks about different categories of names, different family names. You can see the families are going up and down with the different colors, and some of the different groupings have different names. So you can see some of the names of these that you'll be seeing in future years. In this periodic table, one thing that you can see the atomic number is given up at the top of each element, and the atomic number is equal to the proton number in an atom. Here's the breakup then of the subatomic particles in your atom. Your subatomic particles of your atom are your protons, neutrons, and electrons. And so you can see a proton is positive. The AMU in the mass stands for atomic mass unit, and that later is converted directly into grams. And the proton is in the nucleus, along with the neutron, which is neutral, and the electron is located in electron clouds. Depending on the type of model that you're talking with, the quantum mechanical model, we use the term cloud. You also hear the term orbit or shell quite a bit, and that's just referring to a different type of model. Okay, in this breakdown then, what you're seeing is how the subatomic particles are broken up for individual atoms. So when you're looking at your periodic table, you can always find the name in the periodic table and the symbol. And then your atomic number, notice how your atomic number becomes your proton number, because that's the number of protons in the atom. Number of protons in the atom determine what the element is. When you're looking at your atomic mass, the atomic mass off the periodic table will be a decimal point, because it's the average atomic mass working with isotopes, which is also one of your vocab terms. To find your neutrons, which are neutral, you take the rounded number of the atomic mass, subtract your proton number, so in this case 9 minus 4 gives you 5 neutrons. Remember that your protons are positive and your electrons are negative, so that means since you have an atom which is electrically neutral, you have 4 positive charges. That means you have 4 negative charges. If we look down at the potassium in the second example, you can see the atomic number of potassium is 19. The atomic mass is your 39.10. So your atomic number is equal to your proton number, and then to get your neutron number, it would be the 39 minus 19 for 20. And because we're working with atoms which are neutral, your proton number is equal to your electron number. So you have 19 positive charges and 19 negative charges, which equals 0, so that is neutral. Okay, this next one then, first thing to notice on this next diagram is that we are now working with ions. Ions have a charge. So here are the elements from the periodic table, still the element name and the symbol. This is the charge that's given to the element, and it comes from the family, but that's something that you would always be given. Your atomic number is still found the same way. The atomic number is, once again, your number of protons. You can't change the proton number, because when you change the proton number, you change what the element is. Neutrons are found the same way, atomic mass minus your atomic number. Here's what's different. The electron number has been altered to reflect the charge of the ion. So since your ion has a net charge of positive 2, that means we now have 4 positive charges and 2 negative charges. Positive 4 plus negative 2 equals a positive 2. So to make ions, it is always your electron number that changes. If we look at a negative charge, then looking at the sulfur ion has a charge of negative 2. You have 16 protons, so that means you have to have 2 extra electrons, so you now have 18 negative charges. You have 16 positive charges, so positive 16 plus negative 18 gives you a net charge of negative 2.